In this video, we're going to revise length and perimeter. So that involves, firstly, thinking about the units of length. So let's think about the units of length. Well, we can use millimeters, centimeters, meters, kilometers. Now, how do we convert between one to the other? Well, to go from millimeters to centimeters, you divide by 10. To go from centimeters to meters, you divide by 100. And then to go from meters to kilometers, you divide by 1000. Because you need to make sure if you're working in lengths that your units for that shape or object are in exactly the same unit. So you may have to do some unit conversion. Likewise, if you're going back the other way, if you're converting, say, from kilometers to meters, you're going to times by 1000, times by 100, and times it by 10. Now, there are various things you can work out the perimeter of. Perimeter is the length, perimeter is the distance all the way around the outside of a shape. Let's think about polygons or just rectilinear shapes. Let's go for a rectangle. Now, for argument's sake, let's suppose I gave some dimensions to the rectangle. Let's suppose this was w plus 8, or this was w plus 2. If I'm going to work out an expression for the perimeter of this shape, I'm going to add together all the lengths. So the perimeter is 2 lots of this side, so 2 lots of w plus 8, plus 2 lots of this side, which is 2 lots of w plus 2. And if I simplify that expression by expanding the brackets, I get 2w plus 16 plus 2w plus 4. Pulling together the like terms, I get 4w plus 20. Let's give the perimeter an example, an actual measurement. Let's go, the perimeter is 80. So if the perimeter is 80 centimetres, so if we were given that in the question, say the perimeter was 80 centimetres, let's work out what w is worth. So we're solving an equation. So 80 equals 4w plus 20. I'm going to subtract the 20 from both sides, leaving me with 4w. To solve for w, I'm going to divide by 4. So w is equal to 60 divided by 4, which is 15 centimetres. I can now work out that the length of this rectangle is 15 plus 2, so 17, and that the length of this part of the rectangle is 15 plus 8, so I'm looking at 23 centimetres. Now let's talk about circles. You should know already that the perimeter of a circle is called the circumference. So the circumference is the distance all the way around the outside. Usually we use either the radius or the diameter to work out the circumference. So that gives us two formulas. We either use 2 pi r or we use pi times the diameter. Well, obviously the diameter is the full length across from one side of the circle to the other through the middle. Now, let's, for argument's sake, say we were given the circumference of a circle. Let's suppose the circumference of a circle was 10. So in a question, we had the circumference is 10 centimetres. Find the radius. What I've got to do in this case is choose which of these two formulas is easier to use. Well, because I'm trying to find the radius, I'm going to use this formula up here. And I'm just going to place the 10 for the c and sub in. So I get 10 equals 2 pi r. Rearranging to find r, I'm going to divide by 2 pi. So the radius is 10 divided by 2 pi in exact form. Obviously, if I'm not after exact form, I'd work out what 2 pi is and calculate the radius. Now let's talk about parts of circles. Let's talk about sectors. Let's just imagine a semicircle for a moment. And let's just imagine we're trying to work just the arc length out. We'll worry about perimeter of these shapes later, but the arc length of this shape, well, I could do that by imagining that that's a whole circle. I've got, let's say in terms of the radius again. And just this part here, I know is half a circle, so therefore the arc length, so just say RA for example, the arc length for this is a half times 2 pi r. Now this cancels down, but let's look at it another way. This is the same as 180 degrees out of the full 360 degrees in a circle. So I can write, hang on, there's a little mistake there. I can write 180 degrees over 360 times the 2 pi r. So I've got two options for this. Let's talk about a quarter of a circle. Well, again, let's draw a quarter of a circle, something like that. Great. You can imagine a whole circle. A quarter of a circle is 1/4. So I can either work out the arc length here as 1/4 times 2 pi r, or I can say it's as a fraction of the whole circle, it's 90 over 360 times 2 pi r. Now let's use this to come up with a general formula for the arc length of any circle. Sorry, the arc length of any sector. I didn't mean to say circle. So let's have a look at a sector. I'm just going to draw a sector. Doesn't matter what angle we have. Let's just, for argument's sake, call it theta. Obviously, you're talking about the angle that involves the arc length. This here would be the radius of the circle, so we'll call that r, and obviously those two are equal, so that's also r. The arc length itself is the theta as a fraction out of 360. So our arc length, which I've been calling A, is theta divided by 360 multiplied by the circumference of a full circle, which is either pi times diameter or 2 pi r. It doesn't matter which formula you use there, depending on the information you've been given in the question. If you're working out the perimeter of something like this, so this shape here, let's give some values to these. Let's go, theta can be 240 degrees, and let's make the radius 3 centimeters. Okay, so let's say r is 3 centimeters. Let's work out the perimeter of this shape. To work out the perimeter, we need the arc length plus twice the radius. And we'll write that in exact form. That means we don't work it out with a calculator, we just leave it in terms of pi. So the arc length here is 240 divided by 360 multiplied by 2 pi times 3. Okay, 240 over 360 is 2/3. Multiplied by 2 times the 3 is 6 pi. Times all the numerator together. 2 times 6 is 12 pi divided by 3. And that cancels down nicely to make 4 pi. So my arc length of this sector is 4 pi. So if I'm working the perimeter out, let's call it P, I'm going to be 4 pi plus twice the radius, twice 3, because that's the radius. So my answer for the perimeter in exact values is 4 pi plus 6. And that's pretty much an overview of shapes involving length. The only other shape we haven't considered is a triangle. You'll need to watch the video on Pythagoras' theorem to make sure you can work out those lengths.